and thank you to FTA for giving me this opportunity to talk to you today. I will not waste any time. I will just head straight into this presentation. I think that's probably the best thing to do. This presentation is about the economics of the integrated supply chain, and it's about how that chain is linked together. Now, for this presentation, I'm actually focusing on the poultry supply chain because that's my area of expertise. But this same type of economics and the way the supply chain works, really, it's whichever supply chain you're looking at is more or less the same, okay? So, my agenda today is really an introduction, a history and structure of the market of the poultry supply chain, a little bit about the supply chain itself, how it works, what the key performance indicators are, and how everything links together through that chain. Then we'll talk about sweating assets, and I'll explain what that actually is if you don't understand, and then product mix and conclusions. This is really about the journey from farm to fork. In the UK in particular, we use that phrase quite a lot, and it's essentially about how the animals that we see in our farms get to the consumer at the other end. It's a very common phrase that we use, and it really encompasses the whole supply chain. The structure of the poultry industry, first of all, started in the US in the late 1950s, early 1960s. There are three main types of poultry. I'm leaving out things like ducks and turkeys, and I'm just focusing on chickens today. So three main types: broiler breeders, which produce fertile hatching eggs that then go to produce day-old broiler chicks. Broilers themselves, which are grown to produce the chicken meat that we see in the shops or at the local market or wherever you may get it from if you eat meat. And commercial layers. And commercial layers have been around for a long time. You know, they range from they started off as the local chicken in your backyard that gives you your eggs every day, and now it's done on a huge scale. Any of the three main types both fall into a number of categories depending on how they are managed and housed. So we may have caged systems where broilers or broiler breeders or commercial layers are in individual cages or group cages or larger cages of 10 or 15, 20 birds. There are deep litter or barn systems. These are conventional systems where you have a poultry house with lots of space and a nice shavings or coconut hull or husk or rice husk on the floor as the litter system. We also have the free-range systems and organic systems, which are becoming particularly prevalent in Europe and the UK, and it's seen as a more welfare-friendly system by many people. Broilers do have many different subcategories as well, and it depends on their growth rate, their colour, and their breed, and it ranges from one side of the world to the other side of the world. As I've said today, I'm going to focus in on broiler breeders and broilers, the supply chain to me. So starting off, broiler breeders, and I'm sorry if I am refreshing your memories and you don't necessarily need it, but I think it's a good place to start so that we all understand what I'm talking about when I say breeders or broilers or broiler breeders. So broiler breeders produce fertile hatching eggs to produce either the next generation of broiler breeder parent stock, and I'll explain that as well, or broiler chicks themselves. The average cycle length of a broiler breeder is about 70 weeks, and that will be 22 to 23 weeks being reared. So that's where they get their uniformity managed, they get fed to specific nutritional requirements until they reach maturity at about 25, 26 weeks when they start laying eggs. And that is the production cycle, which lasts for about 40 to 42 weeks. Cleaning and disinfection should take around 5 weeks in between flocks. Broilers, well, broiler chicks are produced from broiler breeder parent stock, fertile hatching eggs. The hatching eggs are then sent to a broiler hatchery, as we know, incubated for about 21 days before being placed onto the broiler farms. And then, depending on the product the consumer requires, they will remain on the broiler farm from anywhere between 25 days, which will be about 1.3, 1.4 kilograms in weight, and that would be mainly in the Middle East area, and 70 days prior to slaughter. And the longer they're there, usually the bigger they get, but with restrictions happening all over the world now, growth rates are very much managed. In some cases, broilers may be grown for as long as 120 days, particularly in places like China where they have a yellow bird, that will be grown to maybe 120 days, possibly longer, because they believe that that introduces much more flavor to the product. If you look at it from a genetic to consumer point of view, what we'd say is that pedigree level, so I used to work for Aviagen as I was introduced there, and they were the pedigree people. They hold all the genetics, and they provide their customers with grandparents, okay, which is the next step up. And we've got great grandparents, GGPs, GPs, parent stock, broilers, processing, and then out to the consumer. So those are basically the 7 levels that you would find in the supply chain at the moment. I'm going to deal basically with this section here, and that's parent stock, broilers, processing, out to the consumer. Just to give you a little bit about the world market, okay, and this is for white feathered chickens, and that's your broiler chicken that you see. So Saguna, Venki, Indian broiler, all based in India, they will have a white feathered bird. In Europe, there's about 100 million parent stock that are used to produce broilers and feed the population, export and import as well. In the Middle East and Africa, about 71.3 million parent stock. In Asia, Australia, and New Zealand, then 150 million parent stock. Moving over to Latin America at 101 and 90 million in North America, and that includes Canada. Altogether, that essentially means a total world parent stock market of about 513 million parent stock. What does that mean in real figures? Well, that means that the current consumption of broiler meat around the world that we know of is about 130 million tons per year. Poultry production from 1961 to 2018 has been enormous in many parts of the world. This graph shows us really in tens of millions of tons on the left-hand side, and then along the bottom is the year of production that this was recorded in. We can see, for example, that Asia here, just highlight that, has grown exponentially. It was very, very low on chicken consumption and has increased particularly since 1990, really very, very steeply. And that's because chicken meat has become far more affordable. There's been there's big advances in production, and so more and more people in Asia are eating more and more chicken. But there's a huge range across that as well. So, for example, in Malaysia, they will eat 65.5 kilograms of chicken meat per capita per year. But in India, they'll eat a far less amount, something in the region of 2.5 kilograms per year. So there's a massive, massive range. And that's really about affordability and the whole system that works within those companies. You can see in Africa, we're starting to see the same type of picture that we saw in Asia. So really from 2018 now, we're going to see Africa really take off with chicken production. At the moment, I'm actually involved in quite a lot of African projects where this is the case. The United States and Europe have sort of slowed down. We can see here we're up at just over 20 million tons of chicken meat there. And the United Kingdom has been fairly stable. We eat a fair amount of chicken meat. We always have done. A lot of it is also imported. There we go. Okay. So a little bit about the supply chain. What is an integration when we're talking about poultry? Well, a complete supply chain is parent stock, as I've mentioned, producing fertile hatching eggs that go to a broiler hatchery, onto broiler farms and grown to a specific weight and age, processing plants, sales and distribution, and then out to the consumer. And that's the same in every integration. There's no real difference. So you can see each of these, if you like, is a silo. Each of these is a business operation within the main integration. and they should work all together. And I'll go through the issues of what happens if they don't work together. We also have the feed mill, which will obviously supply broiler farms and the parent stock farms with the feed that they need. And that can actually be run as a separate business too, selling feed out into the industry. Another point to mention here, and it's not really relevant for many areas of the world, but in the rest of the world, what happens is at the processing plant, any rendering product like feather meal and bone meal can sometimes be used and put back into the feed mill to feed the parent stock and broilers. So that's an even bigger part of an integration that may occur. So what makes a good integrated supply chain? Well, essentially, to be a success, you need to be economic, profitable, responsive, and adaptable. Without those three things, then any integration does not work correctly and loses money very quickly. And I've witnessed that on a number of occasions. And you'll see as I go through this, if you're thinking about, if we think really very locally or very recently, COVID-19 has had a huge impact on many poultry companies because they're not responsive and adaptable enough. And I'll explain a little bit more about that as I go through. So it should have a good integrated supply chain, should have a good product mix so that we can supply food service, retail, and wholesale. We should be able to ensure that changes made to one part of the integration will have a minor impact on all the other business units. So if you remember, I showed you the little table there with parent stock, broiler hatchery. If you make a big change on the parent stock side of it, which is the start of the supply chain, then that could potentially have a massive impact on the rest of the supply chain, which may start to lose money if you make the wrong decision and don't tell them about it. None of those business units essentially should work in isolation because that could lead potentially to an overall loss in profitability. It must be responsive and adaptable, which is what I've just said on the previous slides. And we should be able to respond to market changes, any change in competitiveness. We should be able to cope with high volume and high quality at the same time. We should be closely monitoring the whole supply chain process all the way through so that we have consistent product at least cost. If I bring this model up for you, or this diagram up for you, you'll see how it essentially works with a little bit more pictures in there. So this is your broiler farm here at the start, agriculture, bird allocation when the birds are caught and taken out to processing, then processing, distribution, and off to market finally. What happens is we get demand from our customer, so pull from the customer and consumer. And they're variables that can be influenced because maybe we have a product that we want to sell and we can influence the customer to buy that. We might have, I don't know, buy one, get one free or buy three for the price of two, that kind of thing. We can influence how the customer buys our product. On the other end of the chain, though, is the push from bird placements, because these are variables that we can directly control, because once we place a bird here in agriculture, it needs to be programmed in through the whole chain to go out to the market and the consumer. So what are the key drivers of an integration? Well, it needs to be responsive to the market forces and consumer demand, and that's for retailers, food service, and the public. So we can see here our retailer, Tesco, supermarkets in most places of the world now. They have specific needs, they have specific quality, they have specific guidelines. But the integration needs to be able to respond to that to give them the best product. We have food service. So here we have McDonald's, as you can see, McCafe, everything that the supplier does to them, so the integrator does, has to meet specific guidelines so that they can sell their product in their stores. And it needs to be consistent. The other part is the public. Okay, so we can see here a wet market, which are becoming less and less. And even at that stage, if the wet market is buying product, it must meet a certain standard. Otherwise, the people at that wet market will not buy the product. They'll go, well, that's a very thin chicken. I don't want that one. I want a nice fat, plump chicken that's been grown well. So at every level, we need to be responsive to those market forces and the consumer demand to make your integration work. For consistent quality, well, I'll start off by saying breed. There are 2 or 3 main breeds in the world. So we have Cobb, AVGM products, which are Ross, Arboracre, and Indian River. And those products are quite balanced, so they get good breeder performance and good broiler performance. On the other side of it, we have Cobb as well, which has not as good breeder performance, but very, very good broiler performance. So you need to think about where that lies in your integration. Can you afford to have less hatching eggs to hatch and produce broilers, or do you need lots of hatching eggs to get more kilos per square meter on the ground? The other one is feed. It plays a huge issue with how our birds perform. So we need consistent quality all the way through, from the feed right the way through the supply chain to the end. Management is essential. That's why I'm in this business. I started off as a chicken manager, and I love doing that. But management plays a massive issue on how our birds are raised and to what time, and if the environment is correct for the bird and the product at the end. Okay, because if you have poor management, then that impacts directly on the broiler processing plants at the end. The other thing that comes through is obviously traceability. Now, for this situation, there's probably not a lot of traceability, but here for McDonald's and people like Tesco's, then there has to be traceability through the whole supply chain so that we know if there are any problems, we can trace all the way back to where they came from. Economy of scale is also another key driver of an integration. Volume is very much a friend, as we know. The more we produce, the more we can sell, hopefully. But it needs to be treated with great respect, because essentially you need to keep product quality, health and safety, and welfare of the animal, and consumer perception. And these are all drivers for an integration. If I put it this way, and I've tried to do this in a kind of simple pictorial way for myself, really more than anybody else. So we have an integration and it starts to become more and more successful, and volume essentially starts to increase. It gets more and more and more, okay? At the same time, what happens is our product quality increases, hopefully, but we might get to a point where we're producing so much that our product quality starts to reduce, get worse and worse and worse. What happens then is that revenue drops because consumer perception here gets to a point that goes, I don't like the quality of that product, I'm not going to buy it. So your revenue starts to drop. So volume is a friend, but only if treated with extreme respect. There are also things like procurement benefits where economy of scale is of big help, because buying larger quantities of feed supply, for example, or raw material products has huge benefits. It also has its risks, because if you buy too far ahead and then the price drops of that raw material and you spend $10 per ton more, then you will feel that you'll feel that impact within your supply chain and your integration. So I've just discussed about how the supply chain works and what really, we can't keep things in silos and everything has to work equally. We need to communicate across that. I talked about consumer demands, retail wholesale issues, quality, and all that type of thing. That's how your supply chain works. But we need to monitor what actually is happening in that supply chain. And we do that by key performance indicators. And I am aware that not everybody here will know about this because they don't necessarily work within the poultry industry. But I thought I'd just go a little bit deeper into live bird operations. And I'm going to talk about individual KPIs, or key performance indicators, which for me are actually key performance indications, and I'll explain more about that too. What I'm going to use is a calculation called PEF, or Performance Efficiency Factor, and this is for chickens, or Performance Index. And that's live weight in kilograms times livability of a flock in percentage, divided by the depletion age in days of the flock, times the food conversion ratio. So food conversion ratio is essentially the amount of feed the bird needs to get to a certain body weight, and then times it by 100. Really, the higher the PEF when you do this calculation, the better the biological performance. So you may go, great, I've got a really high PEF, I'm doing really, really well. I'm making the company lots of money. If you're talking about KPIs, that's not necessarily the truth, and I'll tell you why as well. Integrations, like I say, KPIs, key performance indicators, are individual key performance indications, okay? So they tell you how you think you're going, but then you need to add the money side of it in. What I've done here is I've looked at feed costs, because feed cost is 70 to 75% of all the money needed to grow broilers. And so if we can save money on feed costs, it means we'll save money potentially on throughout the whole business and make more money at the end of the day. So for example A, what I've said is we've got, using the formula that I showed you, which is this one here, the PEF formula, a 2.55 kilogram bird times the livability, which is 96.4%, will reach that weight in 41.5 days, for example, and it will have a feed conversion ratio, so it will eat 1.6 kilograms of food for every kilo of body weight. Example B says, well, 2.5 kilograms by 96.4 by 41.5 days by 1.65 FCR, okay, so it's eaten 50 grams more feed than this flock per bird, right? Now you may go, well, okay, that's fine. The PEF is 370 for example A, and example B, it's actually 359. And I said to you on the previous slides that the better the PEF, the better the biological performance. And that's proven here. That's correct. That's really, really good. So as a farm manager in my silo, at the start of the food supply chain, I'm going, yes, I've done a really, really good job, right? But if we then start to put money into this, we can see really what could potentially happen. Feed cost, for example A, is $400 per ton. Feed cost for example B is $381 per ton, so it's $19 cheaper than example A. So feed cost per kilogram of live weight is 64 cents in example A, and it's only 63 cents in example B. So even though the live weight, the performance is better, the biological performance is better here than in example B, we are really making more money in example B, even though we've got poorer performance. It's potentially a difficult one to get your head around. It's better performance, but at what cost to the whole supply chain, the whole integration? Example B, it has a poorer food conversion ratio, a poorer PEF, reduced feed costs, and if we think about a 1 million bird per week operation, so an operation killing 1 million birds in a processing plant per week at 2.55 kilograms, we've got 3 cents per bird lower feed cost, which is equivalent to $30,000 lower feed cost per week, which means that we're saving or making an extra $1.56 million per year just because we've got a lower feed cost. But don't forget our performance, our biological performance is worse. As a farm manager, I'm going, no, I don't want the poorer performance, I want the better one. But as a company, it's actually better to have the slightly worse performance because the feed cost to reach that performance is lower. So it's important to understand this and how the better biological performance has actually been achieved. Is it costing you more to get that better biological performance? The costs associated with any improvements and the implications to the whole supply chain. Transparency and communication essentially are essential. So to achieve a cohesive strategy to economic return for the whole business, all these areas need to be talking to each other. And that comes from agriculture to bird to catching, to processing, to distribution, and out to the consumer. The most important profit driver for an integration is essentially the processing plant. It is actually, in most cases, the only part of an integration that makes money because they're the ones that are selling to the consumer at the end of the day. And I just thought I'd put this in because we can see that over time that genetic improvement and bird selection has vastly changed the look of our chicken. You can see on by 1972 it was a tiny little chicken with not a very uniform breast conformation, and here we've got better 1996, and now we're producing chickens 2012 onwards that are vastly different from that in 1972. If we take the processing plant and we have a look at what the impact that actually has on the whole integration, we can use this table, and I'll just go through it quickly, but I need to focus on the last two. The last two sections here are for the processing plant, so eviscerated yield and breast meat yield. So this is hatching eggs per hen house from parent stock that we've been talking about. The performance is maybe 175 hatching eggs. We have a 1% improvement, which is 1.75 hatching eggs, and we get a $0.001 value per kilogram live weight improvement. And that's the same for all the other things. They're only quite small improvements on the biological level there. So feed cost is reduced, and it has a $0.005 improvement or value per kilogram of live weight. But if we look at eviscerated yield, and this is how important the processing plant actually is, because if we can improve eviscerated yield, so that's the yield after everything's been taken out of the bird, then it has a massive impact on the processing plant. Sorry, it has a massive impact on the actual value it gives per kilogram of live weight. Okay, and the same for breast yield. If we can improve breast yield by only 0.25%, here, so 1% improvement, 0.25% over 25.30, we get really a 2-cent value per kilogram of live weight. So the impact of that processing plant is massive. But let's just go back to the example that we were talking about before. So we have example A and example B, and at the moment, example B, as we know, is more profitable, right? Because the feed cost is lower. Even though the performance is worse, it's still better because the feed cost is lower. But if we say, okay, well, example A actually gets a better eviscerated yield, we can sell more of the chicken to the public, and it gets 72% yield. And example B gets 71.5% yield. And if we say, okay, that value is half a US dollar, or half a dollar, half of anything per kilogram, we can see the carcass value is actually greater for example A. So does that offset our increased feed costs for example A, or example B still going to win here? Well, here's the answer based on 1 million birds. A higher carcass value for example A, 10,000 per week higher income from yield, but we have the 30,000 higher feed cost, which essentially says that, well, we're going to lose still $20,000 compared to example B, right? So even though we've got the lower yield, and because the feed cost is lower, we can still lose money compared to example A, which has the higher feed cost and the higher yield. But beware, please beware. The system is very finely balanced. And it's balanced because if you start going, okay, I can make even more money at doing this, I can reduce my feed cost even more, my raw material cost, I can get that down and everything, you start to reduce feed quality. And if you start to reduce feed quality, you get poorer performance. That poor performance impacts on the whole supply chain, and you get reduced growth and yield at the processing plant and on the farm. If you go too far with that, you start to get reduced profit despite the reduced feed cost. Again, I'll use an example A and example B, so it's the same birds going through the system. Eviscerated yield with the improved feed actually increases substantially to 73.5%. The eviscerated yields, for example B, goes down because of the poorer feed, the lower feed cost. Carcass value is different by nearly 4 cents. If we do the 1 million birds per week processed, then the higher carcass value, that's fine, no problem, by 3 cents. 38,000 per week higher income from yield compared to B. 30,000 higher feed costs though compared to B, don't forget. So we can now make 8,000 extra revenue, or $450 million per year compared to example B. Because we've pushed the bird too far in example B, we've reduced the feed cost so much that it's not performing, we then go, okay, we've come out of balance and we're actually starting to lose money. So you can see how important that actually is for the whole supply chain. We need to be able to talk to each other and go, hang on, I'm going to reduce the feed cost. What impact will that have on the broilers, which in turn, what impact will that have on the consumer at the end of the day in the processing plant? The other main broiler KPIs, key performance indicators, are livability or mortality, live weight, so kilos per square meter, so if you want to put it that way, feed conversion ratio, FCR, as we've talked about, age to slaughter, weight in days, average daily gain, so that's how much weight the bird puts on through the life of the flock. And then what we have to remember, and what I've been trying to impress on you, is none of the above KPIs should be used in isolation. Okay, they can all be calculated on a weekly basis, and they can be combined to form an overall picture of flock performance and try and get the most economical way, the biggest profit, the biggest revenue, okay, from combining all those and making an overall picture of what we can do to improve our results. So I'm just going to move on. I've got another 3 subjects to cover. The first one is sweating the assets. Sweating assets to achieve economies of scale is key to an integrated business model. But again, it must be balanced and sustainable and have bird welfare at the forefront. When I say sweating assets, what I basically mean, if you don't know what I am talking about, you have a broiler farm potentially, or a breeder farm with 25,000 birds on it, and you increase the number of birds on that farm. That would be the classic example of sweating your assets. So here we go. We can say increasing bird stocking density, increased throughput is an obvious way to sweat assets. So you've got more birds in the same space that can go to processing. But if you do that, you have to remember that even small increases in mortality and condemnation at the processing plant can have a significant effect. So if you look here, based on an increased target of 1 million birds per week, a 1% increase in condemnations and mortality because we've started to sweat our assets and we've put too many birds in the same place, the welfare's gone, there's not enough ventilation, okay? It's about 10,000 birds a week that we're losing. So you may as well have stayed where you were. At a processing weight of 2.5 kilos, that's 18.4 tons of lost yield per week. $9,200 per week lost, and $500,000 lost a year. Just one thing, I haven't really talked a lot about parent stock, but they do have an impact as well. The hatchery and breeder effect, well, if we say, okay, I'm going to buy a different breed, and that's going to lose me a hatching egg, so I don't have enough chicks to put on the ground, that's essentially a loss of $46,200 worth of hatching eggs, a processing loss of 571 tons, less per year eviscerated yield, and about 285,000 loss per year. So everything has an impact. You change your breeders, you do something differently, you don't communicate it, has an impact on the consumer, as we can see down here. It has an impact all the way through the processing chain. So product mix, very briefly. Product mix is basically what we say, who we should be supplying. And the idea is to have a balanced product mix to survive, essentially. So if you are looking at if you ever get to go into a processing plant or visit an integration, you say, what's your product mix? You should really be looking at something where they're supplying 33% of all their product to retail for supermarkets, that kind of thing, 33% to the food service sector, and 33% to wholesale. You might say, why is this important? Well, again, if we think about something like COVID-19, and I'll use the UK as an example, all food service sector was shut down during COVID-19. What happened is companies couldn't actually move to retail and wholesale, or couldn't get their products anywhere else. So they started to lose money hand over fist. Malaysia, exactly the same issue. Food service closed, and they can't actually change where they want to put the birds because they've got into these agreements that say, oh, we need to supply this much to this customer, and we can't change that, and we can't supply another customer. And so many people had to start either culling out hatching eggs or culling out parent stock and not placing broilers to cope with that change. And that means a big loss in money. So impacts of product mix, it makes a mess of weight accuracy because you don't really know where you're supposed to be supplying to. And also, specific retailers and specific wholesalers have specific weight accuracy boundaries. If you miss those, then you start to do something called giveaway, which is where they're only paying for 1 kilo of chicken, but you're supplying them with 1.2 kilos of chicken. Uniformity of product goes down the road of no return. Carcass quality can be impacted on. Condemnations, catching and collection damage may also have an impact on that product mix, because essentially if you start to have more condemnation and more catching damage at the processing plant, or birds damaged coming into you, then they can't be sold, they can't be used. So you actually lose where you can put that product in your supply chain. Starve out times on farms before birds are slaughtered. I won't go into too much detail about this, but also loss because feed that you paid for has gone into the litter and is still in feeder pans instead of being used to grow birds. Okay, so some conclusions for you. The economies of the integrated supply chain are complex and interlinked. I think, and I hope I've helped you try and understand that there are many, many different parts of the supply chain. They all need to work together. A successful integrated supply chain should be profitable, responsive, and adaptable, as we've talked about, and have a good product mix to survive. Changes made to one part of the integration will impact on subsequent business units, as we've talked about. Business units working solely in isolation may lead to an overall loss in profitability. So the farmer's going, great, got a fantastic result, but is actually costing the company money rather than making it. Working together throughout the whole supply chain requires transparency, communication, and an overall understanding of the integrated business.